Hello everyone, this is the video lecture for College Algebra Math 1414 Section 8.3 Partial Fraction Decomposition. Partial Fraction Decomposition. Wow, that's a huge title. And this will be a big section. I would say that this is probably the last hard section that we have in the class. After this, we got some more that are kind of here and there, but as we get into chapter 9 and onwards, it'll be much easier. So, this is the last big one. Let's do this. Here's the idea. This is just an example. Here's just an idea of what we're going to be doing in this section. I got, let's say 4x plus 5 divided by x minus 2 times x minus 3 all on the bottom. And we're wanting to split up these denominators into two separate fractions, an a and a b. The goal here is to solve for a and b. That's it. That's what we're doing right here. So I'm taking this big fraction and I'm cutting it up into two little fractions with these same factors in the denominator. And somehow I'm supposed to find out what a and b is. It's not 4 and 5 here. I don't know what it is, but it's not 4 and 5. We're going to have to do lots of math to get there. But at least this is the idea. We have to have some rules for how this is going to be going before we can even do the math. So there's going to be a good chunk of your homework that's not even math. It's just going to be kind of like patterns, and that's okay. Let me give you some rules for how we're supposed to approach this, because this is just one thing. We could have all kind of different factors in the bottom. We can have our numerators looking like whatever. Lots of different stuff going on. So here's some rules. I'm going to say each, and there's a lot of English, each numerator is generally, love that in math, generally going to be 1 power less, like 1 degree. I'm going to say degree. Power is fine, but degree is more technical. 1 degree less than its denominator. Okay, do I have any more? Oh, descending terms. That's a very important piece. Descending terms. Every piece of English up here is actually very important. Sometimes I talk and talk, but this is actually really important. Okay, each numerator is generally going to be 1 degree, 1 power less than the denominator, than its denominator, and we need to have this descending terms thing. Let's do an example. Let's say I had x minus 3. All I need is an a in the top. The reason why? This is a 1 power. This is a 0 power. And that's what we were seeing up right here. See, that's a 1 power. That's a 0 power. It's 1 less. Okay, well, that was easy. Let's say that I had, I'm just going to do the denominator first. I got x squared minus 3x plus 5. It doesn't really matter. Let's say that this is my denominator. Well, what I need is an ax plus b. Now, I want to show you why. We have a 2. Now we have a 1. But I have to keep going. I have to descend my terms downward. So I also have to have a 0. Let's do another one. Let's say that I had a big denominator. X cubed minus x squared plus 9x minus 8. Just something like that. Well, what I need now is an ax squared and then plus bx plus c. Again, 3 and 2, so it's 1 less, but then I have to descend down all the way. I have to descend my terms. Now, here's the thing. If we're faced with this kind of denominator, like over here, on this side, not over here, I'm saying on this side, we're going to have a lot to do. A, B, and C is just for this one fraction. And, well, there's other fractions by necessity. And so, let's not go there. I mean, I'm sure your homework isn't that bad. I have done the homework. It's been a little bit, but It is a lot, but I don't find it terrible. So here's another rule. Repeated factors from your denominator, descend to a single power, descend to a 1 power. I'm going to say 1 power. I like that. A 1 power. Not degree here. Each of them retain the numerator from the simplest expression. Simplest? I don't know how to spell it. I'm saying it. Simplest expression. Okay. Now, what is going on here? Let's do a thing here. Let's say that I had x minus 3 squared. This is my original. Well, I have to descend down until I get my 1 power. Okay, so there's that. And then I'm looking at this last one for what the numerator is going to be. This guy is going to be just a single letter. So I'm going to have an A and then a B. Again, this is a 0 because this is a 1 power right there. Let's do another example because this could be kind of weird. I got x squared minus 3x plus 5. And let's call it cubed. Well, if I have a cube, I now have to also have a square. Hold on. And then I also have to have the 1 power. And then I look at this 1 power and say, well, what is the numerator that I would have for this? It's an ax plus b kind of format, right? Because again, there's a 2, there's a 1, and then I descend it down. Well, the thing is, I can't put a and b over here because they start way over here. Ax plus b, and then I have cx plus d, and then I have an ex plus f. Solve for 6 variables. This is only one thing. We got another fraction after this. My point is, it can be really crazy. It can be really crazy. I have a little note here. This is just a little note. It says, sometimes I tend to overdo it. Can you see why? So I'm going to check with my math lab and see what they want as we go. And so what I did is I was going through the homework and I was verifying that I wasn't radically crazy. I'm parentheses happy. I like a lot of parentheses, but was I overdoing it? And I don't think so. 831. Here we go. I've got 11x minus 10 divided by x minus 4 and x plus 8. Now the cool thing about these first few problems, it's just setting it up. Just the setup. Like what you've been seeing me do with the a's and b's and stuff. And so I need to set this up. Well, there's 2 different factors. They each get their own fraction. Notice that this is a 1 power, so I get a 0 power, just a constant. And the same thing here. 1 power, so I get a 0 power, and just, we're done. That's it. It was super easy. Wow, that was easy. I like that one. I got 833. I got 9x squared plus 24x plus 2, all divided by, I got x minus 4. X plus 4 squared. I'm actually going to have 3 fractions here. Reason why, I got the x minus 4, that's easy enough. I have the x plus 4 squared, but because I have a square, I have to descend its powers down to a 1 power. You don't have to write the parentheses for this, but it's whatever, 1 power now. And then I have to fill in the top. Notice that this is a 1 power, so that just gets a linear term at the top. I'm sorry, not linear, a constant term at the top. Constant term here as well, because if you see here, this is a 1. Therefore, I'm going to get, like, you know, ax0, just a constant term again. But then I have to do that again for both of these. They both get that same style. So a B and then a C. That's your answer. We're done. We're just setting it up. Just setting it up. You might be having a lot of questions at this point, and I understand. There's one in particular that I'm going to address here in a second. Just kind of hang on. So here, again, I'm going to have two fractions. I got the x squared plus 6 squared, and then I got the x squared plus 6. You know, this one doesn't make a lot of sense to me, honestly. This is still your homework, but it doesn't make a lot of sense. Reason why is because wouldn't I just keep my fraction as like the first one? I mean, it's kind of already simplified right here. Like, this is that. Why do I need another one? I don't know. Maybe the homework's just weird. Anyways, well, I'm looking right here, and I got a square, and so therefore I'm going to have an ax plus b kind of format. Again, it's a 1 power, descend down, all that kind of stuff. Well, I can't put a and b over here. I'm going to put a and b over here. So ax plus b, and then cx plus d. Now, what you might be asking is, what about the numerator? What about the numerator? Did I do anything with this numerator in any of these problems? The answer is no, I did not. I don't even talk about the numerator yet. We will in a little bit. We're going to do real math with it. But when you're setting it up, the numerator does not matter. You want me to write it down? I'm going to write it down. I'm going to, hold on. I'm going to use the word don't. I'm going to say the numerator doesn't, it's close enough, affect the setup. Okay. I wrote it down. Means you got to write it down too, yeah? Now we're going to do real math. Can't be sitting on that setup stuff forever. We got to do real math too. Okay. Go. Your first real one. Well, we got to set it up, obviously. So I got two fractions here. X plus 2, x plus 1. And I'm going to have an a, and I'm going to have a b. Again, this is a 1, so this is a 0. This is a 1, so this is a 0. I don't have anywhere else to go. I don't have anything else to do. So we're good here. That's my setup. What I'm saying is that this is equal to that. This equals that, somehow. And solve. Solve for a and b. What do? I'm going to multiply these to the other side. And to both of them. And I'm going to show you this one time. One time, I'm going to show you this the long way. And I'll never do it again because it's way, way too long. See, they're in the numerator now. They were in denominator. I'm multiplying it on both sides. Now they're in the numerator. You shouldn't do what I'm doing every single time. It's good. This is good. This is good practice. But notice that if you think of these as factors, cancel, cancel. We're left with this. Okay, now pause for a second. Pause. That's the slow way. There's a quick way to just jump to this without having to write everything. I call it the numerators are multiplied by their opposites. Multiplied by their opposites. Multiplied by their opposites. What does that mean? Notice that the a had an x plus 2. Well, now a has an x plus 1. B had an x plus 1, but now b has an x plus 2. See how they're multiplied by their opposites. That does not work every single time. I give this a good 90% working. This works 90% of the time. If it doesn't work, again, I'm going to show you maybe one or two that doesn't. But you would just do it the long way like this. You know that something's going to cancel. That's the idea. You don't want fractions. In fact, I don't think you'll ever get fractions here. If you get fractions at this point, we got problems. You don't want fractions. Nobody likes fractions. So do what you can to get rid of them. And you might get something left over like what we have here. I guess I could keep simplifying. I'm going to go ahead and distribute a and b. In a way here, I'm kind of thinking like, well, what do I do? What's the next step? If you were in my class, I'd just sit there and pause. Hey, what's the next step? And I just sit there and wait. wait and wait and wait. um, well, obviously, this is a recording, so you could pause if you want to think about what the next step is, but the idea, though, is I have to keep going. So I distribute. Okay, cool. I'm simplifying, I guess. Now what? Seriously, now what? What do I do? Well, how about this? It's a little bit of a radical idea. What if I combine like terms? What if I combine like terms? What I'm saying is like these x's can go together, and these a's and b's and well, constants can go together. And so I got x times a plus b, and then I've got this a plus 2b. Notice that I'm also using these parentheses to help group them. I want them to be grouped. This is for a good reason. I'm still a little lost about what's going on, but I did it. Yay. Now what? Seriously, what now? We've done everything I could think of. Do these x's cancel? Nah, not really. I mean, you could combine like terms again, but it's not like that. This is what you're going to do. This is radical, but you have to know this is the next step. This is what you're going to have to know to keep going. I'm going to convert this into 1x plus 0. That is all I'm doing right now. I will make quicker work of this on the next problem, but this is my first problem, and I'm wanting to show you what's going on. I have just x, nothing else. Well, how many x's do I got? I got one of those right there. Hey, what's my constant? What's my constant right here? What I got my x's, but what am I adding to the x? Well, nothing. Exactly. Nothing. 0. So why did I write it? Because I want to combine like terms, I guess you could say. Notice that these guys here are in the same family. They're both x's, while these guys here are actually in the same family as well. They're both constants. It's kind of a weird thing. I'm saying that 1x is equal to x times this a plus b. Now you can cancel those x's. I got 1 is equal to a plus b. Hang on to that for a second. Let's look at the other one. I got now 0 is equal to a plus 2b. I guess you don't have to write parentheses. These right here are two equations, two unknowns. Solve for a and b. This is a system of equations. Right here. System of equations. Do you want me to write it a little differently? Well, we got x plus y is equal to 1. And I got x plus 2y is equal to 0. I just converted them over to x's and y's for your eyes to see. Could you solve this? Yeah, I mean, we were doing that last time. And that's why this is in this chapter. That's why you got this partial fraction decomposition in this chapter 8 stuff. Because we now have a system of equations and we need to solve for it. Again, I am going so slow right now. I'm going to go much faster in the next problem. I'm just trying to slowly get through this with you. So what do I do now? How do I start solving? I'm not going to use x's and y's because we had x's earlier and stuff. I don't want to confuse myself. But we've got a's and b's should be fine. What if I say minus 2b on both sides? So I got a is equal to negative 2b. That's something. That's something. Cool. And so then I'm going to take this equation here, 1 equals a plus b. I'm going to replace it. You get a negative b, and thus b is equal to negative 1. You could then take that and plug it back in here. So a is equal to negative 2 times the negative 1. A is equal to 2. And I'm going to use these answers in my final answer. So here we go. Final answer here. I got x plus 2. Got the x plus 1 is equal to, again, remember how we had this. And this is actually a very important thing. We had an a and a b. And this was an x plus 2 and an x plus 1. If you mix these up at the very beginning, if you mixed them up and had a 1 and then a 2 or something like that, then the whole thing will be wrong. Just watch out. Just go back to the original. Check it. Make sure you're doing the same math. And then I replace it. I got my A, I got my B. I rewrite them. There we go. Done. This equals that. You might be wondering, well, why are we doing this? Crazy math. Well, it's in calculus. Seriously, it's something that you'll be seeing later down the road. Let's do another one. 8, 3, 11. I guess, do I even have to say it? 14x plus 46 divided by x plus 2 and x plus 4. I'm going to set this up right now. I got my x plus 4, my x plus 2, and I'm going to have an a and a b. Again, I don't care what the numerator looks like. I'm looking right here. That's a 1, so this will be a 0. 1 and a 0. Cool. So I have this. I'm going to do the quick version. I'm going to multiply this to the other side. And as you already know what's going to happen, you already know this is going to happen, you're going to multiply by the opposites. Because everything else is going to cancel. See? Multiply by the opposites. Super fast. Super easy. I'm going to distribute. Sorry. Okay. Maybe I should be talking during those times. I don't know. It's just a lot of stuff here. And before I even combine like terms, I'm just going to show you. I got X, and I got X. Here's another one. I got number, number, number. So I'm going to write them out. 14 is equal to A plus B. The other one, 46 is equal to 2A plus 4B. Notice what I've done here. First off, I got rid of my x's. I don't really need those. I know they're going to cancel. I know that. I'm just looking at the numbers. The coefficients, I guess you could say. Fancy word for numbers. And then the numbers. So I'm just grouping them according to their terms. Let's start solving. I mean, I don't got a really great way to do this besides just plugging it in substitution or something. Let's move the b over. And so I got a is equal to 14 minus b. And then I'm going to take this and I'm going to plug it in. That's a little bit too close. I'm going to plug it in right there into that a. So I got 46 is equal to 2 times 14 minus b plus 4 times b. Distribute. I got 28 minus 2b plus 4b. You know what? Hold on. I'm going to minus 28 on both sides. I think that'll be okay. And then these guys will combine. I need a calculator for that. So I got 46 minus 28 is equal to 18. And then I got a positive 2b. Divide by 2 on both sides. And b is equal to 9. If I use this right here, then I'll have a is equal to 14 minus 9, which is 5. And so my final answer, if you remember, I had a and then a b. I had the plus 4 and then the plus 2. Is that correct? Let's go back up. Check it right here. See my setup? So I need to just replace a and b. Literally copy paste what I see. Yes, yes, A, B. And there we go. We're done. I hope you saw that that went a little faster. And I'm trying to make it a little faster because I don't want you to take forever as well. I mean, steps are good, but patterns are good too. I mean, this is actually a pattern-styled section here. I mean, the setup part is definitely pattern-worthy. All right, next one. Go, figure it out. I'll just wait here for you. Where are my factors in the bottom? You have to create them. You have to create them. I don't know what they are yet, but I know what two numbers. Multiply it to a 32, but add up to a 4. Da 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 da. 8 and 4. Negative 8, positive 4. That should work. And now I could set this up as 8 and 4. Again, these are both linear terms, so we get a constant in the top of both of them. That's my setup. Here we go. I now take this and multiply it to the other side. So 4x minus 5 is equal to a times its opposite and b times its opposite. See how fast this goes? Go ahead and distribute. So required step. ax plus 4a, bx minus 8b. I guess you could say combine like terms, groups, terms. I don't know. So 4 is equal to a plus b. I'm going to do little squigglies on these guys. Negative 5 is equal to 4a minus 8b. Solve. So I'm going to move the b over, very similar to last time. And I'm going to plug that in. There's not a lot of creativity going on here today. Well, I mean, earlier there was. Not in this problem, though. This is all very similar. I'm going to go ahead and move the 16 over. That's subtracting it to the other side. Thus, I'm going to get a negative 21. And I'm going to get a negative 12b. Yep. Divide by the negative 12. And what we get here is a b is equal to two negatives make a positive. 21 over 12. That actually reduces to a 7 over 4. Now, that's important because I went and typed in the 21 over 12, and it said, no, you're wrong, and it was 7 over 4, and you know how we all get frustrated when my math lab is very picky about simplifying. So please try to simplify when you can to something that's, easy. And then finally, I already have my a here, and so my a is equal to 4 minus the 7 over 4. Again, that's going to be a 16 over 4 minus 7 over 4 makes a 9 over 4. Yep. And that's already reduced. So my final answer, let's go back to the format. We had the minus 8 and plus 4. We had the a and then the b. So the a was a 9/4. And the b was a 7/4. And that is your answer. Cool. I have a note here. I mean, I already mentioned it, but I had messed up. I had messed this up. At some point, I didn't reduce, and then I tried something else, and that messed it all up, and I got way crazy fractions, and it wasn't right. I have a note here. It says, even I mess these up. Often. I have it written in my notes. I wish I could show you. My point is that me being the teacher, I mess these up. Not that you don't have hope for this now. I'm just saying that it's okay to get things wrong once in a while so that you learn and hopefully not do that again. That's the point in mistakes. You learn from them. Also, these fractions here, I think are okay in the numerator. I would not have left them like that otherwise, but there's going to be another problem coming up where you're going to have to reduce these down to, say, 9 and then a 4 like this. In fact, I'm going to write this right beside it because it might be required now. I don't know. My math lab's always changing and updating, not always for the better. So that definitely worked whenever I tried it last, but there is another problem coming up where you need to do this anyways. So just kind of be on guard, and we'll talk about it when we get there. Okay, keep going. 8, 3, 19. I got 4x squared minus 7x minus 3, all divided by x cubed minus x. That's a cube. That means 3 power. Go. Figure it out. What? Oh, wow. I did like a couple steps just to get down to what I needed. Here's the main thing. I need to factor this bottom. Let's just pull it off to the side and factor it for a minute. They both have an x in common. And then you can see right here that that is going to be an x minus 1, x plus 1. That's that perfect square business. If you really, really want to know, that's an x minus 0. Technically, right? The reason why is because that's going to be like solve for x, you're going to get a 0 out of it. I'm not gonna really do that. But my point is that if you need numbers, you know where to get them. Now, I'm gonna take this. This is just my denominator, and I'm gonna, I guess, rewrite it. I don't have to, but I'm going to. I'm gonna go ahead and rewrite it for you. X minus 1, x plus 1, and then it's now equal to 3 separate fractions. We got an x. We got x minus 1, and an x plus 1. And because these are all linear terms in the bottom, we get constants in the top. Whew. Multiply by their opposites. Now this is where it gets weird. What's the opposite of x? It's both of these guys. It's both of them. A times x minus 1, x plus 1. If you did the math, if you actually put all this in a numerator here, here, and here, you would only cancel the x, and you would leave these guys behind. B times, what's the opposite of x minus 1? Well, it's a regular x, and then an x plus 1. Those are the opposites. And finally, C, what's the opposite of plus 1? Is a regular x and an x minus 1. Ooh, lots of math up ahead, and I had to go down because it's just too much for the screen. So I need to simplify each one of these. I'm going to write this out, and hopefully it'll fit. Oh my goodness. Okay, here we go. I know that looks like b of x. That is so not true. It's b times. It's just math notation. And so this guy over here, I definitely have to FOIL out like a lot. Here I can actually distribute, and I could distribute. So a times, and I got x squared minus 1 in the end. We already did that. That's where it came from. Here I got a bx squared plus bx. And here I got a cx squared minus cx. Go ahead and distribute this. And we didn't even have any repeaters this time. Just imagine if we had repeaters, how big this would be. Yeah, that's a lot of math. All of this is supposed to be equal to, get a little bit of room here. All of this is supposed to be equal to 4x squared minus 7x minus 3. So color coding, here we go. Squares all together. I'll just go ahead and write it. So I got 4 is equal to a plus b plus c. All of my linear terms, all my x's, negative 7 is equal to b minus c. And then my constant terms, well, that's all I got here. So I got negative 3 is equal to negative a. Well, that's easy to solve. Yes, that is easy to solve. In a good way. We got 3. If I take that and plug it in right there, what I now have are easy systems of equations. Let me just go ahead and do this one more time. I'm going to minus the 3 onto the other side. I don't know if you can hear, there's raining outside right now. Isn't that funny? That will go down in history. So we have this. We have this set up now, and I need to solve. I want to solve for b right here. You can do whatever you like, but that keeps my c a positive, and, well, I like that. And so I'm going to take that and plug it into the top. 1 is equal to c minus 7 plus c. You don't need the parentheses. You got 2c minus 7. Add 7 to both sides. Divide by the 2. We get 4. And now I go back to, no, actually I want to go back to this guy. I like that one. B is equal to 4 minus 7 is negative 3. Cool. Oh, and we had our A. A, B, C. We have everything. All right. Whew. Here we go. So 3, negative 3, and 4. we had, if you go back, we had 3 fractions way, way, way back, right there, right there. X minus 1, x plus 1. Very important to keep those lined up. X minus 1, x plus 1, and then A, B, and C. Here we go. So I had a 3, a negative 3, and a positive 4. Whew. One last problem that I'm going to do with you. For you, with you, with you. X plus 4 divided by x squared times x squared plus 2. All right. You don't have to factor anymore. It's kind of interesting. We got a repeater here. It's a simple repeater, but I start with it, and then I descend down to the 1 power. So we're good there. And then I had this other term, which is irreducible. You can't do anything else with that guy. If I'm looking at the repeater term here, remember that this is the simplest, and that's a linear term, 1, and so I'm going to have to get 0, thus an ax 0, constant term at the top. And so I'm going to go ahead and use that for both of those. Again, that same format for all of the repeaters. And then over here I got a square. See that square? So I have to have a single term. Oops, that's going to be a D. A 1 term, and then I descend down to a constant. That's my setup. Whew, that was a big setup. Well, here we go. Multiply by opposites. And this is going to be a little weird. So here we go. I got my x plus 4 is equal to... what's the opposite of x squared? Right here. It's just the x squared plus 4 term. But what's the opposite of just x? Well, one of these x's is going to cancel, leaving 1 behind, and then still this big term here. And then I got my cx plus d is still all times. What's the opposite of x squared plus 2? Well, it's just going to be the x squared. Whew, man. Distribute, distribute, distribute. Ax squared plus 4a, bx cubed plus 2bx, or not to be x. Ha, ha, ha. That was a joke. Shakespeare? Okay. And, well, I just go ahead and multiply the rest there. Should be fine. There's a lot going on. Well, let's do our terms. So I got my squares. Ooh, I don't even have squares coming up first. I got cubes. So I'm going to ask you here, right here. How many x cubes do we have on this side? Come on. How many x cubes? We got 0x cubed. Hey, how many x squares do we have over here? Let's do x squared. X squared. X squared. How many x squares do we got over here? 0x squared. Isn't that weird? And I got my x's. That's a 1, by the way. X's. And then finally, numbers, constants. That's a lot going on. So let's do the cubes. I got 0 is equal to b plus c. Let's do these squares, the blue ones. I got 0 is equal to a plus d. Getting some symmetry vibes here. I got 1 is equal to 2b. Right here, the green. And then finally, the magenta, I got 4 is equal to 4a. This one is super easy. A is equal to 1. Nice. And here, b is equal to a half. Cool. Well, let me take this top equation here. I got 0 is equal to b plus c. Oh, I got b. So move it to the other side, and c is equal to a negative half. Take the top one here. 0 is equal to a plus d. Well, I have an a. Move it over to the other side, and d is equal to a negative 1. There it is. Wow, that was a lot easier than I thought it would be. So let's make sure we're setting this up correctly, because there was actually 3 fractions this time. X squared, X, and then the big guy. X squared, X, and then the big guy. This had an A, that's a 1. This had a B, which was a half. This had a CX plus D. A CX plus D. Just wanted to remind you. This is going to be incorrect. It is actually correct. Oh, hold on. Why do I have a 1 there instead of a 2? Hold on. Yeah, why did I get a 4 there? My notes are a little different here. You're going to hang on with me, right? I got a 4 right there. Oh, you know what? Look, guys, I messed up. Oh, man. I'm not going to go back. I'm just going to show you. Notice that there was a +2 right here. So why did I have a +4 right there? It's incorrect. You weren't using ink, were you? Now, I really hope that you see, so that's going to change this guy to be a 2 here. I hope that you could see that I still get some wrong. Yeah, me. I get them wrong. This is a 2 right here. When you do the math here, then, this is going to be 4 divided by 2 is a 2. And then we had a 2 right here, which makes this into a 2. And so then I got a 2. And then I got a 2. Okay. Well, I know it's not perfect, but at least you're seeing that I mess up. Yeah. It was a simple typo. I mean, I just put a 4 instead of a 2. That stuff happens. Yeah, I know, but it you know, it happens. Watch out. The math is all the same. Okay, so this is my answer. Cool. But they're not going to accept it. They're going to go, no, you're wrong. Because we have to change this right here to be that fraction stuff. So let me rewrite it in the exact form that they want. Notice that the 2, I'm bringing the 2 down. And here, I'm actually bringing a 2 down. But when I do that, I now have a 4 in the top. Let's talk about it. This is your answer. Let's talk about it. If I bring a 2, like a half, let's call it a half. I got my half right here. Well, I'm going to say not -2. I'm going to say -4 halves. And so I can bring the half out to the front. I'm going to bring my half out. And then that 2 is actually right there. Leave behind a 4 and a 1. I don't know why I didn't close that off. Grr. That's in my notes. Grr. Because they're very picky about their simplifying. We did it. Whew, man. If y'all have questions, please tell me, because this is wild and crazy. There's a lot going on here. When I do this in class, I actually do this for like a couple days in class. And then I come back and review them with it again later. It's just that much of a topic. But again, I'm still here for you. Ask my instructor button, email, messages, whatever it is. Thank you very much. Have a great day.